Rocky, shh.
Okay, so we'll be continuing our lesson on graphical solutions of simultaneous equations, or what we said as a system of linear equations. Okay, and then we'll be focusing on the point of intersection, or that's the solution of any two lines, and we'll be looking at just linear equations. Okay. The learning intention and the success criteria are exactly the same as what we had with on Tuesday, right? But we'll be looking at different ways how to graph these equations, okay? So let's probably have a look at our warm-up. The warm-up task that I've put there is actually the task that I've asked you to do last lesson. So we said that when it's a graphical solution of these simultaneous equations, then what we're just looking for would be the point of intersection. It's actually the coordinates of the point of intersection, okay? There might be cases, as we will see later, that there might be some lines that will never meet at all, right? Or that there would be some lines that would meet at all points, okay? And we'll have a look at those later, right? But the examples that we've got here for the warm-up would be those lines that will intersect at one and only one point, okay? So let's have a look at the first one. The equations x plus y equals 3, and then x minus y equals 1, right? Wherein this is x minus y equals 1, and this is x plus y equals 3, right? So they have been graphed for us. The only thing we need to do would be to find the point of intersection, the coordinates of the point of intersection. For this one, if we make that larger, then that would be 2, 1. Okay, so that's the answer for the first one. I think this is question 1. I don't know why I didn't copy question 1 there. All right, so that's 2, 1. And you write your point of intersection as an ordered pair, right? When you say ordered pair, they always come in pairs and that they are always in order. All right, what order is that? It's always the x value first and then the y value. Right? So this is your x value, that's your y value. Ordered pairs, pairs that come, numbers or what sets of numbers that come in pairs, and the order would matter. Okay, 2, 1 wouldn't be the same as what 1, 2. So again, we have a look at question B. We're looking at 3x minus y equals 2 for this one, and this is x plus y equals 2. Right? The point of intersection would be 1.0 or just 1, 1. Okay, so you can write B, the answer there is 1, 1. You can even write 1.01, right? And they should just be the same. Okay, and then question C, you have two lines here. This is y minus x equals 4. And this is 3x plus 2y equals 8. And see how I would rather have that over here, just on the right, just so it doesn't look messy. I don't know, it's just me. But usually you don't want to be confusing yourself if it's actually that one is close to that or to this one. So there's no confusion whether what would be what is labeled with that equation. Okay, so this is y minus x equals 4, and that's 3x plus 2y equals 8. And the point of intersection would be 0, 4. So you simply write 0, 4. Okay. Now, I don't think there would be any issues with question D and E. All right. Although with D, your y value would be at negative. Here, your x and y values, let's probably just do them. D. The point of intersection for D would be what? So that's 2. It's a positive 2, but then that's a negative 1 for the y value. So then that's 2, negative 1. Okay. And then for E, both are negative because precisely the point of intersection would be on the third quadrant. And therefore you have what? -2, comma, -4. Okay. Now, the last one there would be just a bit tricky because then that would look like, so you could only just estimate that, but that looks like it's halfway between this point and that point, which I think that's a 1, and then that's a 2. So halfway between them would be 1.5, right? So the y value would be 1.5. The x value would be a negative, right? And that's what, -0.5. And then the y value would be 1.5. Okay, let's have a look at now what we need to do for us. What if it's not graphed for us? What if it's just the equation, just like these ones here that were given, right? And I've asked you to maybe do the ones that are already in the y equals mx plus b form, right? Or you could also put them or rewrite those equations into the y equals mx plus b form before you graph them, okay? Another way to do that would be to use a different strategy in graphing, okay? So there's another way of graphing these equations. Well, the first one that we learned in year 8 is to actually draw a table of values. So if I would be drawing a table of values for this one, and I say that's for the equation x plus y equals 5, I would want to have values that would cover negative numbers and positive numbers. So I might choose to assign x values of -2, -1, 0, 1, 2. Okay, so it depends on what you want to assign for your x. All right. And depending on the values that you assign for x, you want to find the values of y. That's why we call the x value as the independent, and the y would be dependent, because the y value would be dependent on whatever x value you assign, right? So this time we've assigned x as -2. So we replace x with -2. We get -2 plus y equals 5, right? So that we're looking for that missing number that we added to -2 and we get 5. What would be that number? Y must be 7, because -2 plus 7 gives us 5. Yes, so we write that as 7. Next, now we want x to be equal to -1. So we now write -1 plus y equals 5. What's the missing number here? What did we add to -1 so that we get a 5 value? We added a 6, because -1 plus 6 gives us 5. So that we have here y equals 6, and therefore we write 6 there. What if x is 0? So we write 0 plus y equals 5. Then if we added that number to 0 and we get 5, then that number must be 5, right? And therefore that's 5. And you might probably guess that the next one would be 4, and that's 3, right? Because the behavior there would be that when this goes down by 1, this also goes down by 1, right? So now we can graph those points, or plot those points, so that we would be able to graph our line, okay? So that we have this Cartesian plane, right? So we've got -2, 7, 1, 2, 3, 4, 5, 6, 7. So that's -2, 7. And then we've got -1, 6. Then we've got 0, 5, 1, 4. And then we've got 2, 3, right? So that our line would be wait, I can do this. See, patience is a virtue. And then you want to label that that is x plus y equals 5. Okay. Next, we want to maybe use a different color this time, right? Because we are graphing 2x plus y equals 8. Okay. So we want, I can hear Rocky going down from the stairs. You're tired of the lounge and now you're here and smelling me, huh? XY. So again, we might want to use, I don't know why, it's you, Rocky. You're disturbing me. I'm working. Okay, so let's draw our, there. Yeah. This is -2, -1, 0, 1, and then 2, right? So we want to replace the value of x with -2. So you've got 2 times -2. Let me write that. 2 times -2. And when I put brackets, then that means it's multiplication between -2 and 2, right? Plus y equals 8. So that becomes -4 plus y equals 8. What did we add to -4 to get 8? That must be 12. So we say that y is 12, right? And then we replace 2 times -1 plus y equals 8. That's -2 plus y equals 8. Therefore, y must be 10, right? And if x is 0, then you can also just cover this, right? And that 0 plus y gives you 8, then it makes sense that y must be 8, yeah? And now you can see the behavior of that. This one goes down by 1, but this one goes down by 2. And therefore, you can have this as 6 and that as 4, okay? Yes? So that we can now graph our second line, and now we need up to 12. So we can have, so that's, what was this? 7, 8, 9, 10, 11, 12. See how hard that is? Okay. And then you have -1, 10. So that's 6, 7, 8, 9, 10. And then the next one is 0, 8. 1, 2, 3, 4, 5, 6, 7, 8. And then we have 1, 6, and then 2, 4. Okay. And now you want to draw a line through those points. Would have that. Yeah. And looks like that it's this. That's their point of intersection. Let me just label my graph 2x plus y equals 8. Yeah, so that that point of intersection would now be what? This point of intersection is, I thought it was red, looks like orange. It's red on the screen. Anyway, so that's 3, 2. Okay, yes. Now, don't you feel that that was a really long process when you're graphing these lines, when you use your table of values? Okay, it's actually what you call your brute force of graphing lines or sketching these graphs. And then the next one, which would probably be a better way of graphing lines, would be using the intercepts. Okay, so when you say intercepts, they can be your x-intercept or y-intercept. When you say intercepts, those are the points where they cross the x-axis and the y-axis. Okay, so let's have the first equation there, which is x plus 2y equals 10. Okay, when you want the x-intercepts and the y, when you want the intercepts, you would want to set the x to 0 and the y to 0. So it's practically using your table of values, but shortening it or targeting certain points of your line, okay? And remember, you only need 2 points to make a line, right? And this is perfect because then you will have the x-intercept, the y-intercept. You've got 2 points and you draw a line through, okay? So let's have the first example. When you're looking for the y-intercept, you want to set x to 0. What does that mean? This x becomes 0 plus 2y equals 10, right? So now you have 0 plus 2y equals 10. You can just say that's 2y equals 10. If 2y equals 10, then that means it's 2 times something gives you 10. That something must be 5. Yes, so you can have that 1 point there, 0, 5. Yeah. Now the other one is, so this is a y-intercept. The x-intercept would be setting your y to 0. So instead of writing y, you write 2 times 0, which gives you 10. And what's 2 times 0? That's just 0. So you're saying x plus 0 is 10, therefore x must be 10. And therefore you've got those 2 points, 0, 5, and 10, 0. You would be drawing again a Cartesian plane. I'm just thinking of how many points I need. I need 10 over there. Probably, yeah. So I've got 0, 5, 1, 2, 3, 4, 5. Yeah, and then I've got 10, 0. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Now you want a line that goes through those 2 points. That doesn't affect our point of intersection. Okay, and then the other one, now we use a pink one. We want Rocky, no. We want 3x plus y equals 15. So now we want the table of values, but we're selecting just the intercepts. So it is with you've got 0 here, or that when y open the door. So we want to find the value of y when x is 0. So that becomes 3 times 0 plus y equals 15. And this just becomes 0. So 0 plus y equals 15. And therefore you can say that y equals 15, correct? And then here, the next one is you're replacing y to 0, right? That's the value of y to 0, right? So now you want 3x plus 0 equals 15. 3x equals 15, and therefore x must be 5. Yeah? Okay, for the second equation, and then our x-intercept would be 5, and therefore that's here 1, 2, 3, 4, 5. Yeah, and now we want to draw a line through those 2 points. Okay. Right, and it does seem that our point of intersection would be this one here, which is 1, 2, 3, 4. Let me count from here. 1, 2, 3, 4, and then that's 1, 2, 3. So 4, 3. Okay, yeah. And again, it's not that very easy, right? And hopefully the next lessons, which would be solving equations algebraically, right, or with algebraic manipulation, then you would find out that that's heaps easier than graphing these points, okay? The other thing that would probably be the disadvantage of graphical solution is not just that it takes a lot of time, a lot of effort, right, and agony, but also sometimes you encounter some of these equations wherein their point of intersection would be very hard to estimate, whether it's halfway between or if it's a third away, 2/3 away, right? So not all those equations would probably be perfectly aligned and have that point of intersection right at the corner. Okay, does that make sense? But those are just the things that, or maybe some of those questions that you would want to do, and you can use any of the strategies that we've discussed today. You can use the one that we had yesterday as the using the y equals mx plus b, right? This is what we learned today, sketching lines using x and y intercepts. And these are all additional examples through a video that you can watch before you attempt the questions, right? And then this one would be, I think that's the one wherein you've got your table of values there, okay? Now, I would discourage you using this, the table of values, okay? I would want you to be able to use the intercepts or the gradient intercept form, okay? Now, I would also want you to note that with using the x and y intercepts, some of them might not be useful when you do that, such as when your constants would be 0, okay? But looking at these ones here, all of them would have constants, so you should be able to use that strategy for most of them. And just remember, when you have a y equals a constant, that becomes what? Your y value would always be 8. So then it would be a horizontal line, okay? So you can take note of that. When you have a horizontal line, it's not diagonal, it's flat, horizontal, it's y equals a constant number, okay? It can be y equals 8, y equals 2. Where is y equals 8? If that's 5, 6, 7, 8, that would be y equals 8, okay? If it would be y equals -2, then it will cross the -2, which is this one here, right? And that's y equals -2, okay? Now, if it's a vertical line, whoa, if it's a vertical line, you would have the equation x equals a constant, okay? What does it look like? It would look like, purple, it would look like well, it would be a vertical line. So when you have, for example, x equals, let's say 4, and let's draw it here, right? So then it will become 1, 2, 3, 4. This is x equals +4. Okay, so all those would be vertical lines. So those are just some of the special lines that you might encounter in the questions. Okay, now the other part that we didn't discuss yesterday was that when your equations would have multiple solutions, right, then those are what we call coincident, right? So they coincide with each other, right? So just like y equals 2x plus 3, that's the same as 2y minus 4x equals 6, okay? Because they would just be a different form of the other, okay? So those are what you call overlapping lines, and when they're overlap, then they are called coincident lines, okay? The equations with no solution, as what we mentioned last lesson, would be those lines that would be parallel to each other. They will never ever meet, okay? And those are the lines that have gradients that are equal. So we can say parallel lines, no solution. No, I can't spell solution. solution, miss. Right? So when your gradient 1 is equal to your gradient 2, okay? The symbol for that would be the two slanted lines, okay? And then, of course, your perpendicular lines. So it's a special line for any two lines that cross, okay? Because they cross at a certain angle, cross at 90 degrees, okay? And they would look like those two there, right? How would you know from the equation, just looking at the equation, that they are perpendicular lines? It is when M1 is the negative reciprocal of the other, okay? When I say reciprocal, if I would have 3/4, the reciprocal of that would be 4/3. But I don't want to just have the reciprocal, but it must be the negative reciprocal. Okay, so then that means it's M1, and if the M2 or the gradient of the other line would be negative 4/3, then you can say that line 1 is perpendicular to line 2. Okay, all right, and if you do have any questions, feel free to email me, message me. See ya. Stay awesome, everyone. Bye.
Come on, Rocky, let's go.